Imagine a spacecraft no bigger than a paperclip, so small you could lose it in your pocket, yet fast enough to cross the vast emptiness of space at a third of the speed of light. Its destination? One of the most dangerous and mysterious objects in the universe, a black hole. This isn't the plot of a sci-fi blockbuster. It's a real mission concept that scientists believe could happen within our lifetime. The idea comes from Cosimo Bambi, a leading astrophysicist and black hole expert at Fudan University in China. In a recent paper published in the journal iScience, Bambi outlined a bold blueprint: send a tiny, laser-propelled probe on a decades-long journey to a nearby black hole. If it works, the data it returns could rewrite the very laws of physics we thought we understood. From testing the limits of Einstein's general relativity to uncovering the true nature of black holes, this mission could give us answers to questions humanity has been asking for over a century. And while the technology isn't here yet, Bambi believes it could be within our grasp in just 2 or 3 decades. Before we can send a spacecraft racing through interstellar space, we need a destination. That means finding a black hole close enough to reach within a human lifetime. Based on what we know about how stars live and die, there could be one hiding just 20 to 25 light years from Earth. The problem? Black holes are almost perfect at hiding. They emit no light, reflect nothing, and are essentially invisible against the backdrop of space. Astronomers can only detect them indirectly by watching how they tug on nearby stars or bend the light that passes close to them. The good news is that new detection methods are improving rapidly, and Bambi believes we could identify a nearby black hole within the next decade. Once that happens, the clock starts ticking on the race to reach it. Even if we find the perfect black hole, getting there is another story. Traditional rockets powered by chemical fuel are far too slow and heavy for such a journey. At their best, they'd take tens of thousands of years to cover that distance. Bambi's solution is something far more radical: a nanocraft. Picture a gram-scale probe, a tiny microchip attached to an ultra-thin light sail. From Earth, a powerful laser array would blast the sail with photons, pushing the craft to an incredible speed, about 1/3 the speed of light. At that pace, it could reach a black hole 20 to 25 light years away in roughly 70 years. But the journey doesn't end there. Once it arrives, the data it collects would still take nearly 20 more years to travel back to Earth. The total mission? Close to a century, meaning the scientists who launch it will never live to see its results. So why invest in a mission that will take generations to complete? Because the payoff could be nothing short of revolutionary. Once the nanocraft reaches the black hole, it could run experiments no human or telescope has ever attempted. Scientists could finally confirm whether black holes truly have an event horizon, the invisible boundary where escape becomes impossible. They could test if the known laws of physics still apply in such extreme conditions, or if reality itself behaves differently near a black hole's edge. And they could push Einstein's general relativity to its breaking point, revealing whether it still holds up under the universe's most intense gravity. Each answer would bring us closer to understanding not just black holes, but the very structure of space and time itself. For now, the vision comes with a staggering price tag. The laser system alone, powerful enough to push the nanocraft to 1/3 of light speed, would cost around 1 trillion euros if built today. And the nanocraft itself? The technology to build such a lightweight, durable, and intelligent probe simply doesn't exist yet. But Bambi is optimistic. In 20 to 30 years, advances in materials science, laser technology, and miniaturized electronics could make the impossible affordable. Just as supercomputers once filled entire rooms, but now fit in our pockets, the tools for interstellar travel could arrive far sooner than most people expect. If this all sounds too wild to ever work, history has a way of proving doubters wrong. A century ago, scientists insisted gravitational waves were far too faint to ever detect, yet we've measured them. Just decades ago, The idea of capturing an image of a black hole's shadow seemed absurd. Now we have two. Time and again, what begins as science fiction becomes science fact. Bambi's proposal may take 80 to 100 years to bear fruit, but it's built on the same spirit of ambition that has driven every great leap in space exploration. The real question is, when the results finally arrive, what will they tell us about the universe, and will we even recognize the reality they reveal?